All right, this video is going to focus on Dijkstra's algorithm. Dijkstra's algorithm is the algorithm that is actually used to program whatever your map app is that you use to get from where you are to where it is you want to go. This is the algorithm that is used to calculate all those different distances. How many miles is it if I go this route versus this route? How many minutes is it going to take me if I go that route versus this other route over here? So we're going to work on this on a small scale, but this is going to really lead us to, again, something that is used all the time in our lives these days. Now, as we do this particular example, I want you to be aware that I have recopied this graph over and over and over again so that you can see each step as like a snapshot, okay? So that you don't have to watch the entire video again or try to figure out what was there first and what was there second. I'm going to be very intentional, which means this is also going to take some time, okay? So be patient because I'm going to do a lot of rewriting at different times, and it's just going to take time, okay? But this is, again, for instructional purposes. So the steps are written out at the top of this page. You're welcome to follow them, but they're also written out individually as you walk through this particular example, all right? So our goal is to get from Tacoma, over there on the left of our graph, over to Yakima on the right-hand side of our graph. And the numbers are travel time in minutes. So this is how long it's going to take us to get from these different cities to the next one. So the way that this starts is you always start at the end, okay? You begin at the end. So we're going to label Yakima as a distance of 0. And it says mark it as current. Now for me, that means that I fill in the circle if that's what the graph looks like. I might put a little star or a little asterisk by it, whatever I can do to say, hey, this is the one I need to focus on right now. So I'm going to use a little circle, okay? That's the first thing you do. Now, recopy it because this is the second thing you do. And again, I want you to see this kind of like in terms of what's happening, all right? So we start there. And the next thing that you would do is from this particular point, you go to every vertex that is adjacent to Yakima, and we write down the total distance as if we were starting in Yakima and kind of working our way to the beginning, okay? So to get to NB up here, North Bend, it would take us 104 minutes if we came through Yakima. So I'm going to label this as a Y104, okay? From Yakima, in order to go to Yakima, it's going to take me 104 minutes. To Mount Rainier, it's going to take me 96 minutes to go to Yakima. And so I'm going to put Yakima 96. And down here, the P, the Packwood, it's going to take me 76 minutes to go to Yakima. Okay, so we label all of those. And then once you label them, you cross out Yakima, like I'm done with it. Okay, I don't have to go back and like revisit it. I've looked at all of the vertices adjacent to Yakima. And you look at these labels, the Y104, the Y96, and the Y76, and you pick the one that has the smallest time as current, okay? So that's the 76. So we're going to label that one as current. I'm going to color it in. And so now we are at vertex P, okay? Now, again, give me a second here while I go back and relabel, and I'm going to redraw everything I have exactly as it is up there. So I haven't done anything, I've just recopied, okay? And now we're going to repeat this process again. So now we're at vertex P, and we're going to look at everything that is adjacent to P that is not crossed out as having already been taken care of, okay? So we're not going to go back to vertex Y, that's crossed out, we're not going to touch it. We could go to Mount Rainier, okay? Whether or not we go to Mount Rainier next depends on the total time. So to go to Mount Rainier through Packwood, it would take the 76 minutes from Yakima and another 27 minutes from Mount Rainier, which is going to be a total of 103, 27 plus 76. That is greater than the 96 minutes that we currently have. And so we're not going to do anything with that 103 that was not better than 96. We ignore it, okay? However, we can look here at vertex E, which is Eatonville. We haven't been there at all. And so if we take that 96 minutes to get to Packwood and then the 76 minutes to get to Yakima, that's a total of 172 minutes. And that would be if we traveled to Packwood or through Packwood. Okay. So here we are again. We're now done with Packwood. We've done everything we can with Packwood, and we look at the remaining labels that have not been crossed out as visited. So we've got the 104, the 96, and the 172, and our shortest total time is 96, which is there at Mount Rainier. So our new vertex is now, oops, sorry, my pen color switched out. We are now at Mount Rainier. That is our new current vertex. All right, so now I'm gonna again take a minute to recopy everything we have. Now remember, this is something that will just be layered on top of layer on top of layer, but for instructional purposes, we're gonna make sure we can see the steps. All right, so now we are at Mount Rainier, okay? We have 3 vertices adjacent to Mount Rainier. We've got Yakima, which has already been visited. It's crossed out, so we're not going back there. We've got Packwood, which has been crossed out. We're not going back there. But we have not yet been to Auburn. So if we add, excuse me, the 96 from Yakima and the 79 to Auburn, that is a total of 175 going through Mount Rainier is the next spot. Okay, so now we're done with Mount Rainier. We will cross that off, and then we look at the remaining distances. We've got the, at vertex NB, we have a distance, or sorry, a time of 104 minutes. We've got 175 minutes at Auburn. We have 172 minutes at Eatonville. And so our shortest time is our 104 minutes at North Bend there. And so NB is our new current vertex. Okay, that's the one we're going to be looking at. So again, let me rewrite. Okay, and so now we are at NB, we are at North Bend, and we do the exact same thing over again. So from North Bend, we're not going to go back to Yakima. The only other vertex we are adjacent to is Auburn. If we take the 104 that's at North Bend, and then we add the 36, we get 140. Notice that is better than 175 minutes. So I'm going to cross out the 175 minutes. I'm going to replace it with a total of 140 minutes, and that's if we go through North Bend, not Mount Rainier. Okay, now we're done with North Bend, so we cross that one off, and we look at the vertices that have a label to them, okay, and we look for the smallest one. So we've got at vertex A, we have a 140 minutes, and at vertex E, we have 172 minutes. Vertex A is the shortest, and so that is now our current vertex. All right, now in the interest of time, I'm going to pause the video for a minute to recopy, and then I'll join you here. It'll be like a split second in your world. All right, that was super fast. All right, so here we are, ready to start again. We are at vertex A. We're not going to go back to vertex NB. We've already been there. We're not going to go back to vertex MR. We've already been there. So our choice is to move forward, or to the left, I guess, to Tacoma with a distance or a time of 20 minutes. So adding the 140 at A and the 20, we're now at 160 minutes if we travel through Auburn. Okay, now we're done with Auburn, looking at our 2 distances there, okay, the T is the shortest, and so the one other thing that we need to do is mark our Tacoma there, our T, as our current vertex. That is now currently our shortest, okay? And in this case, it would not make any sense necessarily to go backwards, but we do have to look and see if we can do better. Okay, so let me move this up again, and I'm actually not even going to recopy in this case. I think we can see what happens. We're already, if we go through Eatonville, we're already at 172 minutes. Adding 57 minutes to that to get to Tacoma is not going to beat 160, because at 172 minutes, we're already above 160. Okay, so what I'm going to do is I'm now going to, again, pause one more time, recopy this whole diagram so you can see it, and then I'm going to show you how we come up with the final result. So back with you in a split second. Okay, so I've recopied one last time, and we did talk about how E actually is done. We've been through that vertex. We're not going to do any better by using 172 minutes when we've got 160 minutes. So where I'm going to make one change here in the note packet. We're going to work forwards using the distance and the vertex from which you traveled, written by the vertices, to find the shortest path. So the shortest path, we're going to start in Tacoma. Okay, and notice our label right here says next we should go to Auburn. So Tacoma to Auburn. Our label at Auburn says go through North Bend. And then our label at North Bend says go to Yakima. So there's our travel path, okay? And now we're in Yakima. And it will take, and that's what the number there at Tacoma tells us, it's going to take 160 minutes to get where we're going. All right, I know that's a lot to swallow, so what you're going to want to do before you watch the next video is kind of work back through that, think back through that, follow back through what it was we did, and then we're going to work on Dijkstra's algorithm on this next problem. And notice here I've only given us one graph, so we're going to do this all in one graph without having to recopy and redo every single time.